Today what we're going to do is we're going to do what's called complex fractions. And you may ask, what are complex fractions? Well, complex fractions are of the point, or complex division are of the form A over B divided by C over D. And we're going to, in order to understand that there are two ways that we can actually solve a problem of this form. So let's look at an example. So we will look at the example. Three over 4 divided by 5 over 8. And this would be example number 1 in either your workbook or your PowerPoint. So we're going to look, one way to do this is to look for the lowest common denominator or greatest common multiple. And in this case, the lowest common denominator or the greatest common multiple is 8. So now what we're going to do is we're going to multiply both the top and the bottom of this by 8 over 1. So now we go 3 over 4 multiply 8 over 1 divided by 5 over 8 over 8 over 1. And then, of course, here this is 2, and here these cancel out. So we end up with 6 over 5, which is our final answer here. Now, the other method that we could use is, instead of dividing, instead what we're going to do is we're going to take the denominator here and we're going to turn this ultimately into a multiplication problem like we did earlier. So I'm going to erase this. And I'm going to first turn it into a division problem. 3 over 4 divided by 5 over 8. And this will be equal to, and we turn now it into a multiplication problem, 3 over 4 times 8 over 5. And then we see that, again, 2, 6, and again we get 6 over 5. So there are actually two methods that we could use, and the thing is deciding both methods would work on any problem, but one method may work better on some problems and another method may work better on other problems. So what we're going to do is we're going to look at example number 2 on either your PowerPoint or your workbook. And example number 2 is 1 over x plus 1 over y divided by 1 over x minus 1 over y. So what you want to see in looking at this one, which method would be easier to do? Well, in this case, the easier method would be the lowest common denominator method. So we look here and we look here and we see x, y. So we find that the lowest common denominator is x, y. Is xy. And we do similar to what we did before. So now I'm going to take this, I'm going to multiply this by xy over 1, etc. So I get 1 over x, xy over 1, plus 1 over y, xy over 1, divided by 1 over x, xy over 1 minus 1 over y, xy over 1. So now what we want to do is we want to proceed forward just like we did. So we're going to cancel out the x's here. We'll cancel out the y here. We'll cancel out the x here. We'll cancel out the y here. So we've simplified it as much as we could simplify it. And then we end up with 1 times y plus 1 times x divided by 1 times y minus 1 times x. Now, of course, we usually don't write the 1, so the final answer we get is y plus x divided by y minus x, and that's our final answer. Now we're going to look at example number 3 in either your PowerPoint or your workbook. And example number 3 is x minus 2 divided by x squared minus 9 all over x squared minus 4 divided by x plus 3. So let's look at this problem and see what the best way to solve this problem is. Now, looking at it, the lowest common denominator, yes, we could do that, but it would seem that finding the lowest common denominator is not so simple. So what we're going to do is we're going to use the other method, the multiplication method. So we're going to turn this problem ultimately into a multiplication problem. So we're going to do x minus 2 divided by x squared minus 9, and then division x squared minus 4 divided by x plus 3. Now what we're going to do is we're going to turn that into a multiplication problem. X minus 2, x squared minus 9 times x plus 3 divided by x squared minus 4. So there we have that. Now we have solved multiplication problems before, and we're going to solve this one the same way as we've solved multiplication problems before. So as usual, we have to factor, because note that we can factor this, and this is the difference of two squares. So we have x minus 3, x plus 3, and then of course there is this one, x minus 2, x plus 2. So now we want to rewrite this whole thing so that we can start simplifying, and that's what we do. We go x minus 2 over x minus 3, x plus 3, and then continue this on, x plus 3, x minus 2, x plus 2. And now we can start canceling, and here we cancel the x plus 3, x plus 3, and here we cancel the x minus 2, and we end up finally with 1 over x minus 3, x plus 2. And now remember that this, you must put the 1 here. A lot of people forget, remember that 4 pizza pies are not the same as 1/4 of a pizza pie. So you must remember that this is 1 over x minus 3, x plus 2, not just x minus 3, x plus 2. That would be wrong. So you must remember that this is a fraction and it has to have the 1 on top. Now we're going to look at example number 3 in either your PowerPoint or your workbook. And example number 3 is x minus 2 divided by x squared minus 9 all over x squared minus 4 divided by x plus 3. So let's look at this problem and see what the best way to solve this problem is. Now looking at it, the lowest common denominator, yes, we could do that, but it would seem that finding the lowest common denominator is not so simple. So what we're going to do is we're going to use the other method, the multiplication method. So we're going to turn this problem ultimately into a multiplication problem. So we're going to do x minus 2 divided by x squared minus 9, and then division x squared minus 4 divided by x plus 3. Now what we're going to do is we're going to turn that into a multiplication problem. X minus 2, x squared minus 9 times x plus 3 divided by x squared minus 4. So there we have that. Now we have solved multiplication problems before, and we're going to solve this one the same way as we've solved multiplication problems before. So as usual, we have to factor, because note that we can factor this, and this is the difference of two squares. So we have x minus 3, x plus 3, and then of course there is this one, x minus 2, x plus 2. So now we want to rewrite this whole thing so that we can start simplifying, and that's what we do. We go x minus 2 over x minus 3, x plus 3, and then continue this on, x plus 3, x minus 2, x plus 2. And now we can start canceling, and here we cancel the x plus 3, x plus 3, and here we cancel the x minus 2, and we end up finally with 1 over x minus 3, x plus 2. And now remember that this, you must put the 1 here. A lot of people remember that 4 pizza pies are not the same as 1/4 of a pizza pie. So you must remember that this is 1 over x minus 3, x plus 2, not just x minus 3, x plus 2. That would be wrong. So you must remember that this is a fraction and it has to have the 1 on top. Okay, now for example number 4, let's look at example number 4. And example number 4 is 1 plus x over y divided by 2x plus 1 over y. Now again, like we do in all of these types of problems, we're going to ask ourselves, which is the best method? Is it easier to find the lowest common denominator and multiply by it, or is it easier to use the multiplication method? Well, in this case, it's probably easiest to find the lowest common denominator, because if we can rewrite this really as 1, and the lowest common denominator pops right out as y. So the lowest common denominator is equal to y. So now what I'm going to do is I'm going to multiply each of these parts by y over 1 in order to get, and then simplify. So I have 1 over 1 y over 1 plus x, y over 1 divided by 2x plus 1 over y, and then y over 1. So now I'm going to simplify. Well, the y's cancel out, the y's cancel out, the y's cancel out. So what am I left with? I am left with 1 plus x divided by 2x plus 1. And I can't simplify this any further. That's as much as I can simplify it. I cannot cancel out anything because there's a positive sign, there's a plus sign here and a plus sign here. So I am at the end. So this is my final answer. Now let's look at example number 5. And example number 5 is 5 over 6y plus y over x divided by y over 3 minus x. Now we see here that it's broken, meaning we don't have it all across here. So it looks like in this case, again, the lowest common denominator method would probably be the best. So if I was just to put a 1 here as a place marker, and that's why I put the 1 over here, so I remind myself about that, to keep it tidy. So now I'm going to say, well, what's the lowest common denominator here? Well, the lowest common denominator here is 6xy. So now I'm going to rewrite it. So I have 5 over 6y times 6xy over 1. As I say, I put the 1 there to keep things tidy so I don't confuse things. Plus y over x times 6xy over 1. And then I continue on. Y over 3 times 6xy over 1 plus y or x over 1 times 6xy over 1. So there I have it, using the lowest common denominator, and now I'm multiplying both the top and the bottom through by the lowest common denominator. So now I'm going to start simplifying it. Well, I see that I can cancel out the 6's. I can cancel out the y here. In this next one, I can cancel out the x. And here I can say, well, here, 2. And that's all. And here it's just 1 times 1, which is equal to 1. So now I have on the top 5 plus 6y squared on the top. And then here I have 2y squared x plus x squared, 6x squared y. So now I have this. Now again, I want to see if I could simplify all this. Well, this top part, it's not the difference of 2 squares, so I'll just leave that part alone. And let's look at the bottom part here. Well, we have y squared, we have x squared. So what could we factor out here? Well, we see we could factor out 2, because 2 goes into both 2 and 6. We can factor out a y, and we can factor out an x. So we see that we get y plus 3x. Well, to be perfectly honest, we see that doesn't help us very much. So that means that this is our final answer. But I did it just in case to show you that you can simplify the bottom part further, but sometimes even by simplifying the bottom part, it doesn't, or the top part, sometimes it just simplifies, and that's as good as you could get. Now let's look at example number 6. And example number 6 is x over 2 plus 2 divided by x over 2 minus 2. Okay. In this example, I'm going to actually show you how it could be done either method, just in case you have a preferred method you want to do, and you will see how one method could be uses maybe less steps than another method. Again, it depends on the problem. So here I'm going to start out with the lowest common denominator method, which is what we've been doing for the last couple of problems. So we find here the lowest common denominator is equal to 2. So this is going to be over 1, over 1. I'm just going to write that again as a place marker. And now I'm going to multiply each of these parts by 2. So I get x over 2 times 2 over 1. And as I said, I put the 1 here for tidiness so I don't confuse things. 2 over 1 times 2 over 1 divided by x over 2 times 2 over 1 minus 2 over 1, 2 over 1. So here I cancel out the 2's, here I cancel out the 2's, and now I rewrite this as x plus 4, 2 times 2, and here I go x minus 4. So here I have that. So you see, that's how when using the lowest common denominator method. Now let's say that I really don't like the lowest common denominator method, and I really like flipping, because flipping is just the thing I like to do. So, because that's what you do in the multiplication method. Well, what I'm going to do is I'm going to do the same problem now, but now I'm going to do it using the multiplication method, meaning I'm going to turn the whole problem into a multiplication problem. So again, I'm going to start off where I started off. And my problem is x over 2 plus 2 divided by x over 2 minus 2. So now I'm going to have to, in order for me to make this into a multiplication problem, I'm going to have to turn this into a fraction where it's a fraction. I can't just turn it, so what I could do, I can do this, maybe up to this point, plus 2 over 1, all right? And I'll put that in a bracket and divided by x over 2 minus 2 over 1. Now, if you notice, this second part, I cannot just turn it over or flip it over or whatever you want to call it, because this negative sign, the subtraction, is preventing me from doing that. So what I have to do is I have to turn this all into a fraction. So I look at this and I see, well, 2 over 1, remember we have to have the same denominator here in order to do that. We can't have different denominators, so we have to find the lowest common denominator here. So I can have x over 2 plus 2 over 1 divided by, and I see I can have, so I can see that I can have x, or we can turn this into something over 2. So I go x over 2 minus 4 over 2. So does everyone see how what I did is I essentially, this is 2 over 1, but we see that 4 over 2 is the same thing as 2 over 1. So now I can just subtract these two together, and I will get x over 2 plus 2 over 1 divided by x minus 4 over 2. Now that I have it in this form, now I can turn it over or flip it like everyone likes to do, and I can now rewrite the problem as x over 2 plus 2 over 1, and we turn it into a multiplication by turning it over. But I'm not done yet, because now I have to combine these two in order. I can't just multiply it like this, because again, we have different denominators. So I'll do the same idea here. So now I have x over 2 plus 4 over 2 times 2 over x minus 4, and then I combine these two, so that means I get x plus 4 over 2 times 2 x minus 4, and then of course these cancel out, and I get x plus 4 over x minus 4, as I did before, but because I just preferred one strategy, I just wanted to do it blindly, you see how many more steps I needed to do it by this method than by the other method. So, and sometimes it's vice versa. Sometimes if you use the multiplication method for a problem, if you try to do it using this method, it will take a lot more steps. So you want to think which method would work the best for which problem. Thank you.